Here, mathematical induction is used to prove results about sets. Now, the problem statement is that we have to show for S is a finite set with n elements, where n is a non-negative integer, then S has 2 to the power of n subsets. Let P of n be the proposition function that a set with n elements has 2 to the power of n subsets. In basis set, we take the base value as 0. That is the set with 0 elements. We call it as an empty set. This set will have itself as a subset. That is 2 to the power of 0 is equal to 1. Hence, P of 0 holds. In inductive step, as inductive hypothesis, we assume that P of k is true for an arbitrary non-negative integer k. That is, every set with k elements has 2 to the power of k subsets. Now we have to prove that P of k plus 1 also holds. That is, every set with k plus 1 elements has 2 to the power of k plus 1 subsets. For this, let us take the set T with k plus 1 elements. This T can be written as S union, the set with only one element, that is A. Now, A is one of the elements of T, that is A belongs to T. The set S can be written as T minus the set with element A. Now the size of the S is equal to K. For each subset X of S, there are exactly two subsets of T, that is X itself and X union with the element of A, which is illustrated in the figure shown here. Since S size is K, by the inductive hypothesis, S has 2 to the power of K subsets, and each subset of S will have two subsets of T. So, the number of subsets of T is 2 into 2 to the power of K, that is equal to 2 to the power of K plus 1. This leads that P of K plus 1 holds. Hence, it is proved for all non-negative values of n that if a set is having n element, then it will have 2 to the power of n subsets. Here, mathematical induction is used to prove the result of covering checkerboard's problem by polyominoes. Here we consider the problem statement that show that every 2 to the power of n by 2 to the power of n checkerboard with one square removed can be tiled using right triominoes. Now let us see what a triomino is. A right triomino is an L-shaped tile which covers three squares at a time. Now let us start the solution. Let P of n be the proposition that every 2 to the power of n by 2 to the power of n checkerboard with one square removed can be tiled using right triominoes. Now let us use mathematical induction to prove that P of n is true for all positive integers n. In the basis step, let us take the base value as 1. That is, we will be having 2 by 2 checkerboard. There are four possibilities for removing one square from this. You can remove the lower left square as shown in the first figure, or the lower right square shown in the second, upper left square removed shown in the third, and upper right square removed in the fourth. In all these four cases, we can tile using one right triomino. Hence P of 1 holds. In inductive step, let us assume that it is true for some positive integer k and P of k holds. As a inductive hypothesis, then we'll have every 2 to the power of k by 2 to the power of k checkerboard with one square removed can be tiled using right triominoes. Now we have to show that it is also true for P of k plus 1, that is any 2 to the power of k by 2 to the power of k plus 1 checkerboard with one square removed can be tiled using right triominoes. Now let us consider a 2 to the power of k plus 1 by 2 to the power of k plus 1 checkerboard with one square removed. Split this checkerboard into four checkerboards of size 2 to the power of k by 2 to the power of k by dividing it in half in both directions. Since one square is removed from 2 to the power of k plus 1 by 2 to the power of k plus 1 checkerboard, as shown in the first figure, it results in no square has been removed from three of these four checkerboards and only the square is removed from the fourth 2 to the power of k by 2 to the power of k checkerboard. This fourth checkerboard can be covered by right triamino by inductive hypothesis. Now let us take the other case also and let us assume that temporarily we have removed one square from each of the 2 to the power of k by 2 to the power of k checkerboards as shown in the figure 2. Those blue squares indicates the squares that are removed. Since each of the checkerboard is of size 2 to the power of k by 2 to the power of k, each of them can be covered by right triominoes by inductive hypothesis. Hence, the total 2 to the power of k plus 1 by 2 to the power of k plus 1 by checkerboard is also covered with right triominoes. Hence, p to the p of k plus 1 is proved and it holds. Hence, it is proved even for all values of n